Hey everyone, welcome back to another episode of the BotPod in our Tech Talk series, where we delve into the cutting edge world of robotics, AI, and today data. And I'm being joined by Dr. Oscar Mendez, Head of AI and Data Science at Locus Robotics and visiting Associate Professor at the University of Surrey. So, Oscar, it's great to have you with me today. How are you?
Hi, thank you. I'm very good, and it's very nice to be here. I really enjoy the work that you're doing.
Oh, thank you so much. And I guess to kick us off, it'd be awesome if you can give me or us a little bit of background and introduction on yourself, your journey, and what really brought you into AI and robotics, and I guess your role at Locus as well.
Yeah, so I'm currently the head of AI and data science at Locus Robotics. I deal a lot with like how we build AI, how we integrate it into our product, and how we develop, AI that is fit for purpose and fit for the warehouse industry. My career has taken a bit of a turn. I started my career in robotics and AI around 2013 with my PhD. And I spent about 10 years in academia kind of building a research lab from the ground up. I ended up supervising, millions in funding, several PhD students and postdocs, and basically running a research lab that focused on AI applied into robotics. So a few years ago, what brought me to robotics was this like real emphasis on like getting the robot to do the thing. I always found that was like ultimately, the benchmark can say one thing, but when you deploy it on the robot, if the robot doesn't do the thing, that's not great. But at the same time, if the benchmark doesn't look great, but the robot is doing the thing, then you know you've accomplished something, and that was really important to me coming out of academia. At some point, I realized that getting the robot to do the thing was turning into getting the robot to do the thing that delivered value. And so I looked at a lot of robotics companies in my career as an academic, and then one day I met Locus, and when they explained their business model and what they were doing, I was immediately hooked. And so I applied, and here I am, and it's been great so far. Yeah. The other thing I wanted to say is I'm a visiting senior lecturer at the University of Surrey, and I'm also a member of the British Machine Vision Association. I'm on the executive committee, so we kind of like host the computer vision community in the UK, and it's something that I also take very seriously.
Awesome, thank you. And I think from a lot of our conversations before, we've spoken a lot about, driving measurable ROI, the robot doing the thing. And that's where I guess we've led into today, where we're really chatting about a topic that not just is a top of your mind, but is a top of a lot of people's minds in logistics, robotics, and AI. And it's how the robots or AI can really drive measurable ROI, why domain expertise matters, and why real data, especially in like vision or complex environments, is super critical,
Yeah.
right?
hmm
So I guess this will kind of lead us into like the early wins we see here. So I feel like back in the day, AI and robotics, it sounded so futuristic and it felt really futuristic. But from, conversations I have or like working in this space, same as you and I, it's here, it's now, and it's kind of a reality. So like tell me a bit more about where you see the delivery of measurable ROI today and getting the robot to do the thing.
So yeah, it's an interesting point. Like AI seems to be this kind of like um woolly undefined thing, this term that like keeps evolving. It's a moving goalpost. So I try to classify AI into kind of three broad categories: statistical, machine learning, and what we call AI. And that what we call AI kind of keeps moving ahead. So a few years ago, if you did any deep learning, people called it AI. Now you're gonna have to be in the realm of generative and LLMs to really kind of fall into that category. And deep learning is kind of more being referred to as machine learning, if that makes sense. Um, but the reason I kind of position it that way is because that makes it very obvious that AI is here. AI is already on our robots. It's already delivering value, and it's already deeply integrated into all of the ways in which robotics in industry are delivering ROI for companies. Um, but obviously, what people really ask is like about LLMs and that all of that kind of fancy new AI stuff. And so when I think about how we can see early wins or where we're going to see them, to me, it's going to be a lot about not using AI as a black box. It's going to be about kind of very surgical and targeted use of AI for specific problems that you have in your workflows or in the problem that you're trying to solve. So being able to listen to your domain experts, to understand what the pressure points are, to use what I call AI sprinkles, little bits of AI that connect the dots between in the workflows that you have, is a way to unlock like really quick ROI. And it's also a way of kind of training your workforce to be more, AI first in their way of thinking. And it kind of comes back to like meaningfully integrating AI into those workflows. So from the logistics domain, I always like to make the distinction between, using AI to pick up a box is not the same as integrating a box picking robot into your workflow and delivering higher throughput in your warehouses. So the wins are going to be when you focus on the latter, not on specific capabilities, if that makes sense.
So definitely that integration piece and how it works in a day
Yeah,
to day. Okay, really
yeah.
interesting. And I guess that then leads it a bit into like impact. So when you guys or companies as a whole in logistics are measuring impact, like talked about the KPIs, everyone's favorite word, but the KPIs that you should be focusing on to really understand the value that you can gauge from this artificial intelligence, whether it's an LM or like those deep learning processes or vision systems.
Yeah, I mean, to a certain extent, there's a couple of things that you can look at, and it will be very dependent on the task in the industry that you're working in. So specifically for the logistics industry, we look at things like lines per hour, how much we're picking in a warehouse, how we move the needle on that. Um, but as you start to explore these things, what again becomes really important is that you engage with people that know the domain that they're working in. So having someone that is an AI expert that doesn't have a history or a deep understanding of the problem domain that they're working in means that they miss some of the wins. So like in some of the work that we're doing right now, what we're realizing is that moving the needle on throughput is important, and we obviously do that, but also being able to be more predictable in the way that we do things, to increase that predictability. That becomes something that actually is quite an early win and a good ROI for the system. So it's about having domain experts that can tell you what the pressure points in the system are, and then being able to measure those. And again, it comes back to this idea of like, don't use AI black boxes that prepare entire systems, targeted use of AI to fill in the gaps and the pressure points. And then one thing that you can also look at that you can look at for KPIs is um, how much your team understands AI, and how much your team is able to understand what they're doing, build the AI in a bespoke manner, and kind of slowly climb that ladder towards more complex AI. So these kind of small targeted approaches tend to deliver early ROI and help train your team for the more complex and larger scale deployments that you want to do. And then obviously the other one that you have to look at for KPIs is data. How much data are you collecting, and how much are you using that to build your AI?
So I guess just touching on something you've mentioned there and that we speak about quite a lot is that domain expertise piece. So look, if there's like an early stage team or a team that's starting out and great, the founders come from a massive scale organization already and they want to build something new, great. They've got the domain expertise, they just want to use it differently. But then what happens if we're looking at like, I don't know, a super early stage team that's just starting out where they haven't necessarily worked in this domain before, where they've come from like a research background maybe, so not had the real world implementation access, or yeah, it's just not something they've worked. They've had a really good idea, can see the ROI conceptually, have a great business plan, but lack this domain expertise that you talk about being so important. So with that, would you say there are like early stage wins that smaller scale deployments can achieve before they scale? And yeah, like what are they? What do they look like in practice?
I mean, I've heard it said that like 90% of AI is just data engineering. And I kind of like take that, to a very large extent, it's true. Preparing the data tends to be a big part of model building. It certainly is when I'm doing the research side of things. And it's definitely true when we're building models for production. Um, and but the way I think about it is it goes back to engaging with the industry that you're working in. So if you've got a small team of a ton of AI experts that really know their deep learning, the first problem that they need to the first question they need to answer is, what problem are we trying to solve? You know, what KPIs does my customer care about? What are we trying to optimize for? And being able to answer those questions and then being able to tie those KPIs back directly to your optimization. I kind of always think of deep learning as like, take the thing that you want to optimize, the KPI, and then make sure your network can directly train for that. And if you can achieve that, then that obviously unlocks a huge amount of power um, for small teams. Obviously, leveraging off the shelf and pre-trained models is something that becomes incredibly powerful. LLMs, obviously, everyone uses them, and being able to access those in the clouds is incredibly important. But being able to take a model that is open source, that is available, that is pre-trained, and and then iterating on that with your own data that you've collected because you understand the problem and you fine-tuned it for the domain that you're working in, that's where the real value comes from. So I don't think for a lot of companies, the early wins are going to be on this kind of like very exciting deployment of LLMs at scale, because the cloud costs end up being so expensive. It's going to be about building your AI capability with bespoke models that you've built and deploying them for something that is fit for the domain that you're working in.
Okay, interesting. And I think then me tracking back a little bit, and you mentioned the value of data, and I think the phrase "data is king" is kind of everywhere, right? So it's a phrase
Yeah,
I probably hear almost daily as a recruiter. I'm sure you have been pounded into your very existence over the years,
yeah.
and I think we touched on this before as well, is why good data is like essential, and it's not just the
I mean,
simulation data
I
that's enough, right?
and I should have said that. I mean, one of the key early wins is data. I mean, the minute that you can confidently discuss the data that you've got about the problem that you're trying to solve, that becomes a true unlocker of value, because it's something that really unlocks the power of AI. Simulation helps. It can get you a fair bit of the way, but the sim to real gap is a very real research problem in a lot of different domains. And there's a lot of ground to cover, and there are papers coming out every year on closing that gap. My field of expertise within AI is computer vision. And in computer vision, the overwhelming understanding is that anything that you train on simulation is not going to generalize to the real world. There's too many like nitty-gritty patterns. There's too much randomness. There's too much, like, the textures are too detailed. So what ends up happening is that at the end of the day, AI is a glorified sort of like statistical model. It just finds statistical patterns in the data, and so it will very happily find statistical patterns that are because of the simulation, not because of the thing that it's trying to simulate, and it'll latch onto them. There are some like amazing examples of AI overfitting in hilarious ways. Um, there's a couple of urban legends about like detecting tanks, and there's one about facial detection. But at the end of the day, if all your data has a statistical bias in it, like if everyone has a red shirt in your data that should be classified as a certain thing, it'll start looking for red shirts even though it doesn't have anything to do with it. So simulation helps debug some of the things, but it's only the data that is going to let you learn those meaningful patterns and allow you to not overfit and to not, build a statistical model that isn't fit for the real world.
Mm. I think it's really interesting you mentioned the kind of sim to real side of it when we are evaluating data, because I've seen actually some early stage teams pop up who have basically built software platforms where you can put in your own prompt, right? And thousands of iterations of your like simulation will come up that will obviously speed the iteration process and then, help for a hardware build. But then we need to put that into practice, which is a whole nother story.
Yeah.
And I guess you kind of said that, some urban legends and some really like good stories about
Yeah.
that, like you said, with kind of
We can go
the
into
red
those.
shirt problem. I mean,
They're
I was
interesting. There's one urban legend about detecting American and I think it was Russian tanks.
okay.
Um, and this was back in the day, many years ago, and they built a model that worked really well on all their training data, and turned out that when they deployed it in the field, it wasn't working very well. And it turned out that they captured all the pictures of American tanks when it was really sunny, and they captured all the pictures of Russian tanks when it was cloudy. And on the day they deployed it, it was cloudy. So all the American tanks were being detected as Russian because the model learned that if it was cloudy, it was a Russian tank. So it overfits so much to the things that you show it. And there was another really good one. Like at the time, it was it was all over the news when it came out. I think it was OpenAI that trained a model that could do hide and seek in simulation. And they were like, "Oh, this agent is amazing! Like it's learned to break the system." And so what the agents would do is like instead of playing hide and seek, hiding behind something, the person hiding learned that if it stood on top of the person seeking, they would never find them. And that's because the simulation was only looking forward, right? So the AI learned to game the system. And
Yeah.
that's what it'll do. It'll game the system on your simulated data. That would never happen in the real world because obviously you would notice if someone sat on top of you. But yeah, simulation just yeah, it just makes it easier to overfit to the data.
I think some of those are like the perfect examples of how like in like complex unstructured environments or supervision heavy environments, the data quality is a massive like influencing factor on that. I think I really like the anecdotes. Like it makes this more fun for me as well when I kind of picture it.
Yeah.
And I think that kind of, leads us on to talk about various models from like LLMs and, different vision systems that everyone's like favorite word nowadays seems to be like Gen AI, right? And it's been like a bit of a hype. It's dominating like the news or headlines, or it's everyone's new like pretty tool. But in robotics, like not every shiny new model like actually adds value. Like sometimes classical robotics is the way to go, mix a little bit of this like modern model, right? So talking about like the AI applications that you see as delivering like real impact, whether it's for, your team or like out there in the real world that you're like, hey, actually, yeah, that.
Yeah, so there's a huge amount of value that a ton of different AI technologies can deliver. And then again, it kind of goes back to how you think about what defines AI. So obviously we can talk about like, multi-agent orchestration being something that is driven by AI. They're driven by certain AI technologies. And that's something that's already delivering value today. We can talk about a lot of what we call explainable AI. That is something that we as a company try to focus on when we're building AI for our customers. We make sure that AI is trustworthy and that we can explain what happened to our customers. And sorry, there's a cat here. So,
So
um,
yeah, the
so
Spotify version of this is not going to know what's going on.
yeah, sorry about that. So so explainable AI becomes something that becomes really important. It's being able to not have an AI black box, to break the system down, and to have individual modules that do AI and that are connected in ways that you understand. So at Locus, we've got a huge amount of explainable AI. We've got something called system-directed labor, which is where we're using an AI model. I don't know how much you know about our solution, but our solution is really straightforward. You come up to a bot, you take an item from a shelf, put it on the bot, and then the bot, you press a button, the bot goes away to the next pick, and then you go find another bot. SDL just does a really simple interaction that says at the end of that pick, the bot goes, go to aisle 8. There's a bot waiting for you there, and it just tells you where to go. But behind that really simple interaction is a huge AI optimization that we're running over the entire warehouse, and that's already something that we've deployed and we've got value on. Um, we've got AI for doing things like collision avoidance and object detection to make sure that we don't crash into things. And again, that's already deployed and delivering value. And more, what we're starting to do is integrate LLMs, but we're not doing that in a kind of black box way. We're actually pulling a lot of our domain expertise from different sources and combining that with like live fleet data to give people access to an interface where they can have a chatbot, have a kind of conversational LLM interface that they can talk to. So there's already a huge amount of value being done.
Okay, interesting. Thank you. Um, and I guess, you've already kind of answered the question I was going to ask there about like deciding on like the right tool for a particular robotics problem to get the robot to do the thing.
Yeah.
But I guess, it's a lot of that is training data, simulations, and like real world application of like how this is going to be implemented. So that's good.
Yeah,
Um,
I mean it's a lot of, I mean, again, for the right AI tool for the job is a lot about listening to your experts. Obviously you have to have robotics experts, but also you need to have experts that are that understand the vertical that you're working in. And how the robot fits that solution, how the AI fits the solution. So because what is ideal for the AI or for the robot might not be the right solution for the vertical, and so finding the right way to make those things work is really important.
cool. Um, and I guess kind of on that leads us, oh, I'm going to track back a little bit actually to where we talk about complex environments and how like, sim to real has to work in real, whereas we've seen, with autonomous driving where like the cars all stopped in San Francisco last year and they were all beeping at each other, like complex environments, unstructured environments. Or wasn't there a study about cars not being able to detect sheep and dogs versus like plastic bags on the road? So it didn't know like whether to stop or to like divert. And I guess, taking it back to a warehouse environment, like arguably more structured than being on a road, but there can still be, yeah, highly structured, but also semi like chaotic environments. So we can't
Yeah,
make assumptions about,
yeah,
oh, well, a warehouse looks like this, has rows and pallets, and it has to do this. But so how do you kind of handle the difference between what is technically a relatively structured environment for like a logistics warehouse, but it's still needing to take account for those unpredictable, like
yeah.
unstructured situations that will come into play?
Yeah. I mean, again, one of the things that I have to point out here is that our AI solution, particularly our nav stack, is an explainable AI solution, and that tends to do a lot better than any of the kind of state-of-the-art visual language action models, for instance, because those are black boxes, and what tends to happen with those is when they go wrong, you can't really understand why, and more importantly, you can't really explain it to your customers. So a lot of these generative models are a bit harder to integrate into highly unstructured and unpredictable environments. Um, at its core, though, a lot of this AI is like I said before, pattern recognition. It's a statistical model. So one of the things that we try to do, and obviously our explainable AI solution is um, works in brownfield sites completely unstructured. We don't need any special infrastructure. We don't need anything, apart from a simple mapping run and just having the robots be able to localize themselves. But all of that technology is all on the robot. It's very very little infrastructure that needs to be added. I think we add some stickers every once in a while just in case the robots get lost.
Yeah.
Um, but then once you've got that really unstructured, that ability to navigate these really unstructured environments, what you can do is you can use that as a platform for data collection. You can use that to try to get an awareness of the site that you're operating in. And then once you do that, you can train your AI to start to pick out these patterns. And so one of the things that we do, and I've been talking about domain expertise in the sense of you want to know where to deploy your AI, but it's also the domain expertise also tells you something about how you should design your AI in the first place. And so having a kind of structured, unstructured, semi-structured environment like a warehouse helps us gives us insights into how, because we understand them, it gives us insight into how to build those little bits of AI machinery. Um, and so at Locus, what we're doing is building something that we call warehouse foundation models. And these are a set of AI models that are bespoke, sort of warehouse first, right? We built them for the warehouse. That means that we need to train them on a lot of data, a lot of real data. But at the same time, they're working in an environment that is less diverse than, say, the open road. So if you think about some autonomous driving companies are building driving foundation models, they need to be able to operate in the entire world. We only need to be able to operate in warehouses, and
Mm.
for a lot of in a lot of cases, we actually have more data um, than some other companies in the autonomous vehicles domain, and we've got a less complex domain to operate in. So, we think this is a very executable and very straightforward thing for us to do.
Oh, definitely. I guess by building a set warehouse or multiple set warehouses, you've got, well, that can be a semi-unstructured environment. Once it's built and it's trained and got its stickers for mapping and planning, you're
Yeah,
kind of sorted with a few variables in play. But yeah, you're looking at a car on a road, there are not only so many situational
yeah,
environmental tasks that need to be kind of programmed into it, but there's a lot more road,
yeah,
right? And
yeah.
there is in
And I
terms
mean,
of the warehouse you're training on.
yeah, don't get me wrong. We have to deal with a ton of like unpredictable behaviors and people doing things, and even down to like the way that people like the way that different cultures interact with robots. Like we have to be able to handle that. Some people like to stand in front of the robot to see what happens. Some people are very deferent to the robot and give it a ton of space. And all of that is something that our robots handle seamlessly.
I think it's really interesting you kind of bringing the cultural aspect of it of like I speak to my friends quite regularly, but they go, "What do you do?" And I'm like, "Well, I recruit in the robotics industry," and they don't still really get it because they don't see it in practice. But I go to summits or demos, and I'm quite comfortable interacting or being around a robot. I think I'd be probably one of those that would stand in front of it to see what would happen. But I
Yeah,
go,
yeah,
"Oh,
yeah,
it's not going to run into me because it's got a sensor that it knows to stop." But
yeah,
most people who don't sit in this space would be like, "Oh my God, I'm going to run a
yeah,
million miles from it." So
yeah,
I definitely get that. And I think sometimes I take advantage of the fact that I work in this space and I understand it to feel more comfortable with it
yeah,
than the rest of the world that aren't
yeah, yeah,
so au
yeah.
fait.
Yeah, no, and people anthropomorphize robots all the time as well, right? And they assign personalities and reasons to their behavior. So these are all kind of really interesting things that from an academic point of view, I find really fascinating.
Oh no, I think we could go off on a whole like different tangent talking about this,
Absolutely,
but I'll
absolutely.
take us back slightly. But look, there's we were talking about the deployments, the various kind of situation-based tasks of which you've like programmed in for like warehousing structured environments to like, super unstructured ones and how those challenges differ. But I guess for you specifically, like when you're deploying these in, the real world setting that is your warehouse, like what were like the early stage like challenges you guys like faced? Is there anything you'd be like, hey, I'd love to like talk about how we overcame this like
Yeah.
a few years ago?
I mean, honestly, the hardest one is domain adaptation. Going from a simulation to a real site is it's almost like starting from scratch. There's so much that you need to change and generate and so much data you need to collect on a new site. Um, Going from one site to two is quite hard. You've deployed on a site, it works. And then you go to a second site, and again, you find yourself that you're having to do a lot of the same things again. And one of the things that we've noticed is that going from 100 to 101 is a lot easier, right? Like you've got all the data, your model generalizes, you've tried it, you found all the little bits of corner cases in the data, and you've got them in your training. And so once you deploy to the 101st site, that's not as challenging as it is because the model now generalizes. So we find that like some of the models that we're building took a while to get there, but we've now got the data and we've now got the expertise to actually, when we go to a new site, it's a lot more straightforward.
Mm. And I
Um,
think, oh, sorry.
yeah, go on.
No, actually, I guess that's a really interesting point when you're thinking about, like the importance of due diligence in data collection as well for those like complex environments. Like you couldn't get to 100 if you hadn't done all of this due diligence data collection for 0 to 99.
Yeah,
It takes all of this early stage work to get there that once you've kind of got it locked down, 100 to 200 to
yeah.
300 and
Yeah, and like not all data is created equally, right? Like
of course.
you have to understand that like, going in and just recording like 60, a 60 frame per second camera just sitting in the corner of a warehouse is not going to be as useful as having sort of like meaningful, rich data. And so one of the reasons I joined Locus and one of the reasons I find the work we're doing really exciting is that Locus has, 350, more than 300 sites spread out across the world. 17,000, 16,000 robots, more than 15,000 robots operating in the field 24/7. So there's a huge amount of breadth of data because we are in many different sites in many different industries. And there's a huge amount of depth because we just got so many robots operating across that. Um, and so that lets us be very diligent in the way that we capture our data, in the way that we structure those pipelines, and the kind of data that we ingest, the kind of data that we process. And at the same time, and where it really like unlocks power is it lets us, because of the way that we operate, it lets us pair that data, that robot sensor data, with business data and mission metadata. And that like quality of data becomes so important when you're trying to solve problems because it means that now your AI is not just looking at like whether it can detect the thing or whether it can pick up the box. It's looking at how it integrates into that business, into that mission, into that like execution of the thing that your customer cares about. And so like you're absolutely right. Like doing that due diligence and building all of that capability is incredibly important.
Yeah, no, definitely. Like, I love your kind of perspective on it as well. And I guess kind of from that, like we've spoken a lot about sim to real, but also domain expertise, which I'd kind of like to track back to a little bit because, building these systems is not just about algorithms, it's about the knowledge that is being kind of pumped in from the background. So I guess for you, someone who's come from, like a research and academia background into an industry team, like how do you cultivate this like domain expertise in your team? Like, do you want to have one person and filter it through? Do you want to kind of embed that as you're scaling?
Yeah, so I mean, there's a couple of things that we do. The main thing is that we're not just looking for people that are like huge experts in AI. We're looking for people that have, maybe some expertise in AI, maybe some expertise in the logistics industry in the area that we're operating in. Um, but largely we're people we're looking for people that want to learn, people that are interested in growing and that have I get excited about the data. I get excited about the AI that we're building, and we're looking for people like that. I'm a visiting professor at a university, so I know how to teach people about AI. I can teach people about logistics. What I can't do is really, you know, give people that thirst for knowledge.
The drive.
Yeah, one of the things I definitely look for is um, I look for people that don't have this syndrome of like the AI hammer, right? Where you've got a hammer and everything looks like a nail. And I want people to be able to say like, no, like actually we don't want to use an LLM for that. There's a much easier way of doing that here. So I take that very seriously, and obviously, I'm all about building that expertise. And part of the reason that like I say that you need to build your AI strategy in these kind of incremental building blocks towards something larger for sure. But incremental building blocks not only help you deliver ROI early, they help you train your team and build that expertise internally as you go along.
That's really interesting. I think kind of with that then, like what do you see as like those common issues or like mistakes that people kind of fall into when they're trying to comply like climb this complexity ladder, if we call it that?
Yeah. Yeah, I mean, people, particularly with AI, they tend to try to run before they walk. There's a huge amount of like, let's just throw data at the AI and see what happens. And sometimes that works. And I think part of the problem that we see now is that it gets you like 90% of the way. When you first try it, and then you think that the next 10% is going to be easy. And a lot of the time that next 10% is like active research, right? Like you got 90% of the way because it was like an off-the-shelf model or because it was a cloud available platform. And then you're like, oh, the extra 10% should be really easy. All I have to do is to get it to do this. And suddenly it's like, oh, actually, that's an active research problem that is being worked on at the moment by the top research labs in the world. So, yeah, the models are too complex. They need too much data. They're too expensive to run. All of these kind of corner cases suddenly become difficult. But I will go back to the most common pitfall is not taking the time to understand the domain that you're working in. Like, oh, we can solve it with AI as a blanket statement without really trying to to really grok what you're trying to do. It
Mm.
just like, yeah, people deploying these AI black boxes, and thinking that they're going to solve the problem domain. Just one of the things I've started asking people to do is a little thought experiment in your head, and it's a bit patronizing, but bear with. I just sort of say, right, if you have if you think you can solve the problem with AI, just in your head replace the AI with the word AI with the word magic. If the sentence flows about the same, then maybe you need to go into a little bit more detail. That's not to say it's a bad idea, but maybe you need a little bit more detail on how you're going to do that. Um, so yeah, that's one of the things that I recommend that people try to do, and it kind of helps avoid that kind of AI hammer situation.
Yeah, it's almost like they get excited by like, the word and the concept. They're like, "Well, AI can do this," without thinking, "Well, have people try to? If they have tried to, why can't they?" And it's
Yeah,
all about, really getting the robot to do the thing.
yeah,
But it's harder than it sounds like. Oh yeah, as you said, you could take a pre-trained model. Great, that was really easy. Well, yeah, that's someone else's research data and work that you've just decided to lump onto it. And I think it's really interesting when you say like the word. It's kind of funny when you say the word magic because I think that's what a lot of people sometimes think AI is. They're like, oh, well, I want something so that can do it for me without
it's
really
a
thinking the steps before that are going to get them
yeah.
there.
And it's AI is an opaque system, and I don't really blame people for that because it's a complex, um big machine that isn't always very easy to understand. So yeah, it happens.
Um, and I guess kind of with that, we've spoken a lot about the mixture of domain expertise and research and that kind of mix from, yeah, research background to real world implementation. But for you, like as someone who comes from a strong like academic background, like an associate professor, like what trends have you seen or like what trends do you love from like academic research that you think are like most relevant to some of these real world logistics applications today or things that you're implementing as well?
Yeah, I mean, there's a lot of really interesting areas at the moment that are being developed. I can talk about like, I'll do it in two parts. So one is the stuff that is close to my heart and that I think is really cool. And
That's
the
my
other one
favorite
is,
stuff.
yeah, and the other one is the stuff that I think is actually going to be really useful. So I think starting to bake reinforcement learning into some of the ways that we do workflow processing in the logistics industry is going to be huge. Um, and um, and by that I don't just mean like, oh, have a reinforcement learning system that picks up the box, have the robot do the thing. I mean, have a
Invitation.
reinforcement, yeah, have a reinforcement learning system that meaningfully integrates your robot into the workflow, right? Like it's not just picking up the box, it's picking up the box and achieving a higher throughput because of that action. How do you integrate that capability into the warehouse? And I think being able to use something like reinforcement learning, some kind of like iterative, self improving learning is going to be really powerful. We're doing some of that in my team, and it's getting really interesting. Um, and then close to my heart. So that's what I think is this kind of multi-agent reinforcement learning driven orchestration and integration of all of these agents in an agentic AI that is both kind of physical. You integrate physical agents, which are the robots, but you also integrate labor, and um, you also integrate some of the equipment, and then you integrate virtual agents and LLMs and all of these systems being combined into a multi-agent orchestration system that is trained with RL or trained with something like it. I think it's really exciting. We're starting to see systems like that come out of academia, and we're trying to build something along those lines as well. So I think that's going to be really interesting. Closer to my heart, there's a huge advance coming out of monocular vision, cheap cameras. Uh, Back in the day, we struggled to do object detection. That's now a solved problem. Drawing bounding boxes on objects is not only solved, but it's really cheap and it's easy to train. And it's a really good starting point for teams that are starting to build that capability. But as you go into deeper and more interesting things, semantic segmentation, depth estimation models, like we now cracked the ability for cameras, you record a video of your warehouse and AI can learn how far away things are. without any supervision, without any like annotation required. Um, so starting to incorporate a lot of these capabilities into platforms that give you more information about your warehouse and give you that awareness of what's going on. I think that's going to be huge. And that, like, I call it site awareness, is again something that we're trying to build and something that is um, really only been unlocked in the last few years. And then the last thing that I'll mention, which because I think it's awesome, is neural rendering. Neural rendering is this technology that lets you do photorealistic renderings that are trained using AI. They can be used for simulation. They can also be used for data augmentation. And there's a lot of like interesting ways that you can incorporate that into your workflows. You need underlying high quality data, and then you use that to train an AI that like augments the power of your data. It's incredibly interesting and incredibly powerful.
And I think, like, again, your passions lean into what you do every day, which is this like criticality of data, but not just collecting it, it's using it in the right ways to really
Yeah.
progress your application, be really valuable for those deployments. So that's really interesting. And yeah, you literally followed on exactly with what I was going to say about data there. So that's great. Um, well, no, I mean, I have like thrown so many questions at you, and I think it's been a really, really insightful chat so far, Oscar. But is there anything that I've missed today that we should shout out? Anything that, yeah, you want to bring to me at all?
Um, I have to think about that. I mean, it's interesting to. I always thought that going from academia to industry was going to be a difficult jump, but I found that a lot of what I'm looking at Locus, a lot of those constraints that the applying robotics to a real problem gives you. Um, I find that those are like stimulating the creative juices, if you will. So my research is now like a lot. I'm suddenly very interested um, in research problems that unlock some of the problems that I see in the world and or at my work at Locus. And so I find that that's blue sky research that is sort of geared towards real world problems is a really cool place to be. And one of the things that, like, randomly we talked about it earlier, that I'm interested in is that, like, interaction between personalities, cultures, and robotics, and how they're going to integrate into our lives. And how people like interacting with robots. That's something that, like, I find fascinating, and I think we need to explore a little bit more.
That's a whole nother data stream that we're going to be collecting.
Yeah, exactly. It's gonna be really fun. Like, I think we're in the infancy of understanding. We went through it with smartphones. We didn't really know how
Mm.
people like to interact with smartphones. There was a period of time we all thought we wanted keyboards on phones, and then we didn't, right? It
Now
just kind of
everyone is
went.
glued to a
Yeah,
plastic screen, right?
yeah, exactly. And now it's just a giant screen, and no one really wants to go back to keyboards. So I think we're at that stage where we're still trying to decide what the best way um for robots to interact with us, or what kind of embodiments we like. And I've got my own opinions, but, like, I think it's just a fascinating time.
I mean, if you want to share your opinions, this is the exact place to do it, right?
I mean, yeah, I think that like purpose-built robotics is the way forward. I think
Oh
that
yeah.
there's going to be a really interesting, like, in the same way that I think that, purpose-built AI that is, like, targeted and bespoke is the best way forward. I think for robotics is the same. A robot that is designed and does one thing really well is the way that I think it's going to end up being. Just because having very large multi-purpose robots is not necessarily something that everyone can afford. It's not necessarily something that is easy to integrate
Mm.
into people's lives or into businesses' workflows. So
No, completely. Um, I mean, look, I mean, so from getting, the robot to do the thing to like my favorite quote of yours, which is AI sprinkles.
yeah,
Um, so yeah, value deliverables, like the ROI, there's been so much change in robotics, but not only that, but data itself and how data engineering and deep learning has progressed over the past few years. It's only going to, really go on this upward trajectory and see how things change. So I'm really excited to see how that goes, and I've really appreciated your insights today. Um, So yeah, I mean, Oscar, thank you so much for joining me. It's always awesome to chat to you, and it's been such a pleasure to have you on as a guest.
Thank you very much for having me. I'm very excited about all of this stuff too, and I just can't wait to see where it all goes. So thank you very much. It was a really nice chat.
Oh, thank you. Cheers.
Thank you.